I am Arthur Francis Deban. It's been a while now, but it's a pleasure to be with you again. So for those of you who may be checking this site for the first time, I will advise you to subscribe and press the like button, and also to ensure you go through all the videos. For the chemist, it is very important you take your time and go through them elaborately. You have questions, you send them to the question box or so I can attend to them later on. Today we're going to be dealing with pH. pH has a lot of definitions. We say it's the degree of acidity or alkalinity of a substance, a solution of a medium. And also that pH is the negative logarithm of hydrogen ion concentration. Alright, and it is also, or hydrozonium ion concentration perhaps. And we can still define it as the logarithm in base 10 of the reciprocal of hydrogen ion concentration, or logarithm in base 10 of the reciprocal of hydrozonium ion concentration. Now, in our course of dealing with pH elaborately, you should understand that hydrogen ion and hydrozonium ion are the same thing, alright? So, we're going to use them interchangeably based on the questions we're going to encounter. So, for us to proceed with our pH, let's take one of the definitions and make use of it in terms of our calculations, right? So we say that pH is the negative logarithm of hydrogen ion concentration. So if I have pH equals to the negative logarithm of hydrogen ion concentration, it means for me to be able to solve questions that have to do with pH, I must, first of all, know how to get or solve for my hydrogen ion concentration. That's number one. Number two, look for the logarithm of this hydrogen ion concentration. Then the third step for the pH, whatever pH becomes the negative value of the log of hydrogen ion concentration. That is 3 steps. So first step, we know this. Second, we know the log of this. Third, pH becomes negative log of that, if that is clear enough. So, let's take, for example, how do we calculate the hydrogen ion concentration? It is important we know how to calculate the hydrogen ion concentration. So, for that, remember I said for us to calculate the hydrogen ion concentration, let's introduce our reaction of water first of all. So, we say now that when water, H2O, plus another water, H2O, when they react, we have our hydrozonium ion plus hydroxide ion. Okay, this is what we get when we react water with one water molecule and another water molecule. We have hydrogen ion and hydroxide ion. This is the foundation of what we want to start dealing with. So in many of the situations we're going to be calculating for this, the concentration of hydrozonium ion or the concentration of hydroxide ion. So having done this, now this is what we need, or this as the case may be. So what you have seen on the board, say at 25 degrees Celsius, the product, which means the multiplication of the product of these two, of hydroxide and hydrozonium ion for pure water, and any dilute solution of an electrolyte is constant, which means my hydrogen ion or hydrozonium ion and hydroxide ion, the product of these is a constant 10 raised to the minus 14. You don't forget that at what? 25 degrees Celsius. This is cardinal. This, we're going to make use of it a whole lot. So you don't forget that. So having said that, let us take questions first. Our first question to see how we can apply this whole thing. All things being equal. This is very important. Now we say if 0.01 mole per dm cube of sodium hydroxide was dissolved. So let me take the given. So in the given, I have I don't feel like writing. Okay, sodium hydroxide here, we say if 0.01 mole per dm cube of sodium hydroxide was dissolved in just enough water to make 1 dm cube. That's the solution, that's the 1 dm cube. What is the A, hydroxide ion concentration? A, hydroxide ion concentration, that is what they want us to get. And B, hydrozonium ion concentration or hydrogen ion concentration. So any of that. So hydrogen ion concentration. So now we want to calculate that. So we need our calculator. Let me change this. So this has been given. We want to use this question to solve for this and this. Solution. So here we have A, solving for hydroxide ion concentration for OH concentration here. So first of all, this is what we do. This is sodium hydroxide. We have our sodium hydroxide, which will dissociate or ionize to give us sodium plus OH negative. Now, we bring the knowledge of mole concept. 1 mole of this give us 1 mole of this. Now, 0.01 mole of sodium hydroxide will give us X. So our hydroxide ion concentration will be 0.01 mole times 1 mole. So that will give us 0.01 mole per dm cube for the hydroxide ion. So if this is my answer for hydroxide ion, the next question, the B, they say I should calculate the hydrogen ion concentration or hydrozonium ion concentration, which is the same thing. So now how do I get that? Remember we say at 25 degrees Celsius, the product of the hydroxide and hydrozonium ion concentration equals to 10 raised to the minus 14. So if I use that formula, I can get the hydrozonium ion concentration. So remember that. So I say B is for hydrozonium ion concentration. For this is what we have. Remember that the concentration of hydrogen ion concentration and the product of this and hydroxide is equals to 10 raised to the minus 14. If this is true, I'm looking for this. So for this, hydrogen ion concentration times hydrozonium is already 0.101, which is 10 raised to the minus 2, that is what that means, is equals to 10 raised to the minus 14. This is 1.0 times 10 raised to the minus 2, which is the same thing as 10 raised to the minus 2. So looking for this now, I have my hydrogen ion or hydrozonium ion concentration is equals to 10 raised to the minus 14 over 10 raised to the minus 2. And this is equals to, in indices we've been told that when numbers with equal bases are divided, their powers are being subtracted. That is mathematics. So I now have 10 raised to the power minus 14 minus, this is subtracted, minus 2. So this is equal to 10 raised to the power minus 14 plus 2, which is equal to 10 raised to the power minus 12 mole per dm cube. Okay, so now we have that. Can we take another question? That's question 1 has been taken care of. Let's take question number 2. In question number 2, they say given a 4.9 GDM cube, which is the mass concentration of H2SO4 solution. Now we should calculate the molar count. Okay, let's take, this is what they gave us, 4.9 GDM cube, okay, of H2SO4. Alright, then we say we should calculate A, the molar count, B, what's B? Concentration of hydrogen, and C, that of hydrazide. Solution. Let's start with A. Now, if this is our mass concentration, they are asking us to calculate the molar count. So, what is molar count? We have many definitions of molar count, but we'll take one of them, which is mass concentration divided by the relative molecular mass. So, A for molar count, we say molar count is equals to mass count, mass concentration, that's what it means, in GDM cube over relative molecular mass in G mole. Okay, now the mass count is given to be 4.9 GDM cube. And the relative molecular mass of H2SO4 is 98 G mole. When we divide that, let's check. 4.9 divided by 98. This is equals to 0.05 mole per GM cube. Okay, that's our A. Now our B, that says we should find the hydrogen ion concentration. B hydrogen ion concentration. For this, we have to go this way. Remember, we've gotten that of H2SO4, so we have to go by ionizing this. H2SO4, when ionized, will give us 2H plus SO4 2 minus. Now, 1 mole of this is equal to 2 moles of this. Now, the concentration of H2SO4 here, which is 0.05 mole, is equal to X. So, my concentration of hydrogen ion is equal to this times 2, which is 0.05 mole times 2 mole. And this is equal to, let me try again, 0.05 times 2, okay, 0.1 mole per GM cube. I use mole per GM cube because this is concentration. So that's our B. Then our C, let's say we should find the hydrazide ion concentration. Remember, we said at 25 degrees Celsius, the product of hydrogen ion concentration and hydrazide ion concentration is equals to 10 raised to the minus 14. Raised to the power minus 14. And I have just gotten this of hydrogen. I'm looking for this. So, the concentration of OH is equals to 10 raised to the minus 14 divided by, this is 10 raised to the minus 1. 10 raised to the minus 1. Let me clean this other side, please. So I take this in out. Now, the concentration of OH negative is equals to 10 raised to the minus 14 minus 1, which is 10 raised to the minus 14 plus 1, which is 10 raised to the minus 13 mole per GM. Remember I told us that when numbers with equal bases are divided, their powers are subtracted. That is indices. Yeah. So that is that. Now, we know now how to calculate our hydrogen and hydrogen ion concentrations. Now we can proceed to calculate what? Our pH. Remember we say pH is the negative logarithm of hydrogen ion or hydrozonium ion concentration. So now we know how to calculate this. If we get the value pH, we just substitute this inside and we proceed. Monitor. So the pH of a solution can be defined as the negative log of hydrozonium ion concentration or the negative log of hydrogen ion concentration. It can also be defined as the logarithm in base 10 of the reciprocal of hydrogen ion concentration or the logarithm in base 10 of the reciprocal of hydrozonium ion concentration is the degree of acidity or alkalinity of a solution. We know that. So let us proceed by solving questions for us. Question number 1. Let's take out this. It says calculate the pH of pure water at 25 degrees Celsius. If the hydrogen ion concentration is 1.0 times 10 raised to the minus 7 mole per dnq. So they say we should calculate the pH of pure water. We say that pure water have a pH of 7, approximately 7, because it's neutral. Alright? In our pH scale, we have 1 to 6.9 to be acidic. 7 is neutral. From 8 to 14 is alkaline in nature. So when our pH falls between 7, we say it's neutral. If it falls below 7, we say it's acidic. Above 7 is basic. So they say we should calculate the pH of pure water. Let's see. And if the hydrogen ion concentration is 1.0 times 10 raised to the minus 7. So the hydrogen ion concentration is equal to 1.0 times 10 raised to the minus 7 mole per dnq. So with this, they say we should calculate our pH. So therefore, pH, remember, is equal to negative log of hydrogen ion concentration. And the pH is equal to minus the log of hydrogen ion concentration is what? 1.0 times 10 raised to the minus 7. Okay, and this is equals to, I have to use my calculator here. Now, minus, okay, minus log 1.0 times 10 raised to the power minus 7, close bracket, is 7. When you do that, you have 7. So, you see the reason why they told us earlier on that the pH of pure water is 7. It's neutral. So, and that's very true. Let's take question number 2. Calculate the pH of a solution containing 1.00 times 10 raised to the power minus 4 mole per dn cube of HCl. Okay? So they've given us, I think HCl has a concentration of 1.00 times 10 raised to the power what? Sorry? Times 10 raised to the power minus 4. Minus 4 mole per dn cube. Now, this question is not a direct question like the other one. They've given us the concentration of HCl and they're asking us to get the pH. And remember, the pH is the hydrogen ion concentration, negative log of this. So we have to dissociate this, ionize it, and get our hydrogen, calculate the molar, the molar count or the concentration of the hydrogen ion. Then after that, we can now proceed to get our pH. So let's see how that goes. So we come down here, we have HCl. If it's been ionized, we have hydrogen plus Cl negative. 1 mole of this give us 1 mole of hydrogen ion. Now I have 1.00 times 10 raised to the power minus 4 mole will give me X. So my hydrogen ion concentration is equals to this times this, which is 1.00 times 10 raised to the minus 4 mole per dm cube. Mole per dm cube. So now I have my hydrogen ion concentration. That is it. They say we calculate the pH of a solution containing that. So now, what is pH? pH is equals to the negative logarithm of hydrogen ion concentration. And this is the negative log of 1.00 times 10 raised to the minus 4, close my bracket. And this is equals to. So let's see. pH minus log 1.00 times 10 raised to the power of minus 4 is equals to 4. The pH is 4. This is acidic, very acidic, because from 1 to 6.9 is acidic and 4 shows that there is HCl, of course, this is hydrochloric acid, is acidic. So let's move on. Let's take question number 3. Question number 3 says, what is the pH of a solution containing A? Okay, let me write it first. A 0.01 mole per dm cube. This is question number 3. What is the pH of a solution A containing 0.01 mole per dm cube HCl? B 0.01 mole per dm cube H2SO4. If I'm right, yeah. What is the pH of a solution containing 0.01 mole per dm cube of HCl, 0.01 mole per dm cube of H2SO4? Now, we know that H2SO4 is a stronger acid. It's stronger than HCl. But now we want to find out their pH having the same value. So by that, we'll be able to define the acidity. It's more acidic than the other one. So let's see how that is true. Okay, let's take the A. pH of 0.01 mole per dm cube HCl. In doing that, we first of all ionize this, which gives us hydrogen plus chlorine negative. 1 mole of this gives us 1 mole of hydrogen ion, and I have 0.01 mole of the acid is equal to X. So my hydrogen ion concentration is equal to this times this, which is 0.01 mole per dm cube. Now, my pH then, the pH then becomes pH equals to the negative log of hydrogen ion concentration, and this is equal to minus log 0.01, and this is equals to, let's see, it's 2. This is 2. So the pH of the HCl using 0.01 mole is 2. Now B, they say pH of 0.01 mole per dm cube H2SO4. I ionize this to have this 2 hydrogen plus SO4 2 minus. So 1 mole of this is 2 moles of hydrogen ion. Then 0.01 mole of this will give me X. Now, the hydrogen ion concentration in this case here is equal to the same 0.01 mole per dm cube. Therefore, the pH, which is equal to the negative log of hydrogen ion concentration, will therefore be minus log 0.01, which is this. Okay. Oh, that's all. 0.01 times 2. Yeah, what do we get? Sorry, that was a mistake there. 0.01 times 2 is 0.02. So here is 0.02. So here is 0.02. Now our pH becomes minus log, open bracket, 0.02, close my bracket, is equals to 1.669, yeah, 1.69 or 1.7 approximately, 1.70. This is our pH. So, the lower the pH, the more acidic is the substance. The higher the pH, the weaker the acidity. So 1.7 is lower than 2, which means this is more acidic than this. That confirms that HCl is a more acidic substance or compound to HCl. Let's take another question. Question number 4. Calculate the pH of a solution containing 0.001 mole per dm cube of sodium hydroxide. Number 4 says, calculate the pH. Where is it? 4. Calculate the pH of a solution containing sodium hydroxide. Okay. 0.001 mole per dm cube of sodium hydroxide. Okay, let's start. We're looking for the pH. pH is the negative logarithm of hydrogen. Yeah, there's no hydrogen, so we're going to get the hydroxide here. Use the product of hydroxide and hydrozonium, which is 10 to minus 14, to get our hydrogen. From there, we proceed to get our pH. So we ionize that. Solution, we have NaOH ionizes thus to give us sodium plus OH negative. So 1 mole of this equals to 1 mole of this. 0.001 mole of mole per dm cube per dm cube of this will give us X. So our hydroxide ion concentration will be this times this, which is 0.001 mole per dm cube. If that is true, yes, let's proceed to get hydrogen ion, because pH has to deal with hydrogen, not hydroxide. So pH now, we say at 25 degrees, the product of these two will give us, which is hydrogen and hydroxide ion. The product of them will give us 10 raised to minus 14. I'm now looking for this, so I divide both sides by this. So I have my hydrogen ion concentration will be 10 raised to minus 14 divided by the count of OH negative. And this is 10 raised to minus 14 divided by, this is 10 raised to minus 3. That's the standard form, if you remember that. So this is, we divide them, we take commonly to have 10 raised to minus 14 minus 3, which is 10 raised to minus 14 plus 3, is equals to 10 raised to the power, as in the hydrogen ion concentration is equals to 10 raised to the power minus 11 mole per dm cube. Now, the pH is equal to the negative log of hydrogen ion concentration, which we have just gotten. So this would be minus log of 10 raised to the minus 11. And this is equals to what? Let me see. So the pH of sodium hydroxide in that scenario is 11. And this is alkaline. It shows that sodium hydroxide is what? Alkaline in nature. So that is that. Let's take our fifth question. A solution has a pH of 4. What is the hydrogen ion concentration? Number 5. Number 5 says a solution has a pH of 4. pH of 4. What is the hydrogen ion concentration? That's what we're looking for. Solution. Okay, solution. Now we have this. We say that pH is equal to the negative log of hydrogen ion concentration. And now they say the pH is 4. So this is 4 is equal to negative log of hydrogen ion concentration. So if I take this way, I have negative log of hydrogen ion concentration is equal to 4. I only change it. Now if I divide both sides by minus, I will have log of hydrogen ion concentration is equal to minus 4. How am I going to get this? So to get remove this log here, you look for the antilog both sides. So hydrogen ion concentration is equal to the antilog of minus 4, which is equals to the antilog of minus 4 10 raised to the minus 4. Okay, this is 10 raised to the minus 4 mole per dm cube. That's our answer. That's question number 5. Let's take question number 6. Don't know how many we're going to solve, but there will definitely be an assignment. You solve it and send it to the, how do I call it, the session on board. I'll check it. Okay, question number 6 says an orange juice has a pH of 3.8. A, what is the hydrogen ion concentration in the juice? B, what is the hydroxide ion concentration in the same juice? An orange juice. So let me start. An orange juice has a pH of this. Orange juice has a pH of 3.8. 3.80. What is the hydrozonium ion concentration? A. The hydrozonium ion concentration or hydrogen ion concentration is equals to what? That's what they are asking us. That's A. So solution, I have pH is equals to the negative logarithm of hydrogen or hydrozonium ion concentration. Is the same thing. So my pH there is 3.80. Okay. This is equals to minus log of hydrogen ion concentration. So if I bring that aside, minus log of hydrogen ion concentration is equals to 3.80. This, if I multiply both sides by minus 1, I will have hydrogen plus here equals to minus 3.80. I look for the antilog. Both sides I have the count of hydrogen ion is equal to the antilog of minus 3.80. So now, let's look for that. The antilog of that is what? Of this. Of minus 3.80 is 1.58. So hydrogen ion concentration here, 1.58 times 10 raised to the power of minus 4 mole per dm cube. Let's move on. The next question says, B, what is the hydroxide ion in the same juice? So if this is the hydrogen ion concentration in the juice, what is that of the hydroxide ion? Remember that the concentration of hydrogen ion, the product of the concentration of this and this is equal to 10 raised to the minus 14. If that is hydrogen, I'm looking for this now. That's our DU. These are D. So our OH, which we are looking for, is equal to 10 raised to the minus 14 over 1.58 times 10 raised to the minus 4. This is 10 raised to the minus 14 up here over 1.58. Okay. Let me put it this way, please. Now here, a number with equal bases, when they are divided, we subtract their power. So let us proceed by saying 10 raised to the minus 14 minus 4 over 1.58. This is 10 raised to the power, this is plus. So this becomes 10 raised to the power of 10 over 1.58. This is equal to, minus 10. So let's see what we get. 10 raised to the power of minus 10 divided by 1.58 is 6.33. This is equal to 6.33 times 10 raised to the power of minus 11 mole per dm cube. OH negative. So in that orange juice, the hydrogen ion concentration answer is 1.58. That of hydroxide ion is 6.33. Okay. Alright, let's move on. Question number 7. 7 says we should calculate the pH of 0.01 mole per dm cube HNO3 triazonitrate acid. B, pH of 0.05 mole per dm cube H2SO4. C, pH of 0.050 mole per dm cube potassium hydroxide. D, hydrozonium ion concentration and hydroxide ion concentration in solution with pH of 5 and with pH of 1.55. That's a whole lot. Let's start with A. Okay, now we say we're calculating the pH of 0.8 is the pH of 0.01 mole per dm cube HNO3. So let's start, that's A, pH of 0.01 mole per dm cube HNO3. So let's first of all get the hydrogen ion concentration so we can apply to get our pH. That's solution now. I have my HNO3. I will ionize to give me this plus NO3 minus. 1 mole of this guy is equals to 1 mole of hydrogen. 0.01 mole of this will give me X. So the hydrogen ion concentration is equal to 0.01 mole per dm cubed. So if this is the hydrogen ion, the pH of that HNO3 will be the pH is equal to the negative log of hydrogen ion concentration, which is minus log 0.01, which is equal to, let's look for that. Looking for minus log, open bracket 0.01, close our bracket. We have 2 here. That's our A. B, pH of 0.05 H2SO4. B, pH of 0.050 mole per dm cube of H2SO4. Solution. Now we have our H2SO4 ionized to give us 2 hydrogen plus SO4 2 minus. 1 mole of this gives us 2 moles of this. 0.050 mole of this will give us X. So my hydrogen ion concentration of this H2SO4 is 0.050 times 2, 0.1. That gives me 0.1 mole per dm cubed. Now, my pH is equal to the negative log of hydrogen ion concentration, which is minus log, open bracket, 0.1 mole per dm cubed, whatever. This is equals to, am I right? Good. Now minus log, open bracket, 0.1, close bracket, is 1. So that's 1. The pH of H2SO4 with 0.05 is 1. So that's B. Let's look at C. pH of 0.05 mole per dm cube potassium hydroxide. C.